is Caitlin Woodard, and my presentation is about satisfying Minnesota's energy demand with renewable resources. Here's a brief outline of what I will be discussing in my presentation. So let's go ahead and get started. I'll begin my presentation by discussing the problems associated with fossil fuels. As many people know, there is an increase in global energy demand due to the increasing population of the world. Consumption is expected to increase by 56% by the year 2040. To add to this growing problem, non-renewable fossil fuel availability is dwindling. Our oil reserves will last us about 50 more years, coal 250 years, natural gas 55 years. There are also quite a few disadvantages associated with fossil fuels. One of the biggest disadvantages is that fossil fuels produce atmospheric pollutants like greenhouse gases. Now I'll go ahead and discuss the emission of greenhouse gases. Greenhouse gases contribute significantly to climate change. Greenhouse gases accumulate in the atmosphere, causing increased temperatures. These greenhouse gases remain in the atmosphere for hundreds of years. They also negatively affect people, society, and the environment, including plants and animals. Now we'll go ahead and talk about the greenhouse gas effect, as illustrated in this picture to the right. So this illustration shows that the sun shines through the atmosphere, and the surface then warms in the sunlight. The surface cools in the evening, releasing heat. Some of the heat is then trapped by greenhouse gases in the atmosphere. This is a normal process which is magnified by an increase in greenhouse gas emissions. So, Earth is basically heating too vigorously. There are many advantages to using renewable energy, however. Renewables are environmentally preferable to conventional sources that are fossil fuels. Renewable energy also has the potential to significantly reduce greenhouse gas emissions. Renewable energy decreases dependence on imported fuels like oil. And renewable energy also creates economic development and jobs for people of the world. Now, I will discuss the background of wind energy in particular. People have been harnessing wind energy for generations. A lot of people think of Dutch windmills when they think of wind energy. These traditional Dutch windmills were originally used for food production and water transport. But the modern wind turbines that we typically see in Minnesota were originally installed in California during the 1980s to collect kinetic energy from wind. The popularity of these wind turbines soon increased when additional incentives for renewable energy were established in the 1990s and early 2000s. Federal government funding reduced the cost of constructing these wind turbines, resulting in an increase in the number of wind turbines and subsequent increase in electricity generated. This illustration gives a concise overview of how wind turbines work and how they are able to produce energy. Now that we have discussed wind energy, I'm going to proceed to talk about solar energy and give a brief background on solar energy. Solar energy is power from the sun. The power of the sun on a cloudless day is approximately 1,000 watts per square meter. We also have to account for the tilt between sun and land, sun intensity, and cloud cover. So this roughly estimates to about 100 watts per square meter. We're then able to transform this raw power into 4 different ways. 1, solar thermal energy, food, solar biomass, and solar photovoltaic. And we will be discussing solar photovoltaics, and we are going to proceed to talk about solar panels. Solar photovoltaic panels convert sunlight into electricity, and they get their name from the process that they do, which is converting photons to voltage. Typical systems average between 10 to 20% efficiency. This photovoltaic effect was first discovered by French physicist Antoine-Henri Becquerel in 1839. Becquerel studied the effect of light on electrolytic cells. Solar cells were being investigated more so during the 1960s owing to the space programs and satellite developments. The energy crisis also stimulated research. Now I will proceed to talk about solar panels that are popular here in Minnesota. One such company that is producing solar panels here in Minnesota is 10K Solar. 10K Solar PV systems have a very unique architecture. They eliminate serial architecture by utilizing parallel independent connections from cell through inversion. And this enables the system components to independently operate, as depicted in the pictures to the right. This optimizes the system's output. A 10K solar PV system is actually located on the UST Anderson Student Center roof. This solar PV system is 52 feet by 71 feet, which is 3,692 feet squared, which is also equivalent to 0.000342998 kilometers squared. So there is 2,915.46 kilowatt hours per kilometer squared on the UST Anderson Student Center roof. Now proceed to discuss my research questions. I would like to figure out how many wind turbines would be needed to generate enough electricity to power Minnesota, and how much area in square kilometers would be needed for these wind turbines. I'd also like to discuss how many solar panels would be needed to generate enough electricity for each licensed driver in Minnesota to drive a Tesla Model S car, and how much area in square kilometers would be needed for these solar panels. Ultimately, I would like to determine how much combined area in square kilometers would be needed for these wind turbines and solar panels in Minnesota. To figure this out, I will proceed to talk about wind turbines in Minnesota. Minnesota produces 4,786 gigawatt hours of electricity per year. For wind farms, assume capacity density of 5 megawatt hours per square kilometer. Assume net capacity factor of 30%. So a Minnesota wind farm generates approximately 1.5 megawatt per square kilometer. This is 8,760 hours per year. So 1 square kilometer equals 13.14 gigawatt hours per year, which gives us 364.23 square kilometers that are needed to produce enough electricity to power Minnesota per year. This is a square 19.1 kilometer by 19.1 kilometer. The map to the right illustrates a 19.1 kilometer by 19.1 kilometer area of land in Buffalo Ridge, Minnesota. 117 wind turbines are located in this area in Buffalo Ridge, which is located in the southwestern corner of Minnesota. The wind turbines are depicted by blue circles. This area is more than capable of generating enough electricity to power the whole of Minnesota. So the total project area of a wind farm includes directly impacted areas and undisturbed areas, which is depicted to the illustration to the right. Directly impacted areas include all the areas utilized for wind production and areas in immediate proximity to turbines. Undisturbed areas are located within wind farms but are not directly impacted. Undisturbed areas of wind farms could be utilized for solar panels, which could be used to generate power for Tesla Model S cars. So the Tesla Model S car is a full-size plug-in electric 5-door car equipped with an 85 kilowatt hour battery pack. It's at 89 miles per gallon gasoline equivalent, and sales are rapidly growing, particularly in Norway and California. The Tesla Model S car scored a perfect 5.0 on the NHTSA's safety rating. The Tesla Model S has won multiple awards, including the 2013 World Green Car of the Year, 2013 Motor Trend Car of the Year, Automobile Magazine's 2013 Car of the Year, Time Magazine's Best 25 Inventions of the Year, 2012 award, and Consumer Reports top scoring car ever. So with that being said, now we're going to look at powering Tesla Model S cars with solar PV systems. We're going to be looking at sun power solar PV systems in particular. The average licensed driver in Minnesota drives 17,882 miles per year. there are approximately 3,035,553 licensed drivers in Minnesota. So we are going to multiply 17,882 miles per year by 3,035,553 drivers. So this equals 54,296,936,511 miles per year that are driven in Minnesota. So the Tesla Model S runs for about 300 miles per charge. So next we want to determine how many total charges there would be per year in Minnesota. In order to do this, we are going to divide 54,296,936,511 miles per year by 300 miles per charge. And this gives us 180,989,788.37 charges per year in Minnesota. So now we're going to look at the battery of the Tesla Model S car. And the battery for the Tesla Model S car is about 85 kilowatt hours. So we want to figure out how many kilowatt hours per year should be generated. To do this, we will multiply 180,989,788.31 charges per year times 85 kilowatt hours per charge. And this gives us 15,384,132,010 kilowatt hours per year. Next, we need to figure out how many gigawatt hours this is. So to do this, we are going to convert kilowatt hours to gigawatt hours, and that gives us 15,384.132 gigawatt hours per year. So now we're going to focus on the solar panels that would be placed in Buffalo Ridge, Minnesota, that would be used to generate the energy for the Tesla Model S cars. So how many kilowatt hours per square kilometer would be generated per day? This number would be approximately 4,600,000 kilowatt hours per square kilometer per day. So now we need to convert this number to gigawatt hours, since that's what we are working with. So this would be equivalent to 4.6 gigawatt hours per square kilometer per day. So how many gigawatt hours of energy would a 1 kilometer panel generate in a day? That would be approximately 0.9384 gigawatt hours per square kilometer per day. So now we need to figure out how many gigawatt hours per square kilometer that would be in a year. And that would be 342.516 gigawatt hours per square kilometer per year. 15,382.132 gigawatt hours are needed to power 3,035,552 Tesla Model S cars per year in Minnesota. So we need to figure out how many square kilometers are needed to generate enough energy for each licensed driver in Minnesota to drive a Tesla Model S. So 1 kilometer of solar PV panels generate approximately 342.516 gigawatt hours per kilometer squared per year. So to find our magic number, we are going to divide 15,382.132 gigawatt hours by 342.516 gigawatt hours per kilometer squared per year. And this gives us 45 square kilometers per year that are needed to generate enough energy for each licensed driver in Minnesota to drive a Tesla Model S car. This map to the right shows the expanse of solar panels that would be needed to generate the power for the Tesla Model S cars for each licensed driver in Minnesota. So it is a 5 kilometer by 9 kilometer or 45 kilometer squared area of solar panels. The area needed for solar panels is depicted in yellow. And this area of solar panels could easily be situated within the undisturbed area of the 19.1 kilometer by 19.1 kilometer area of wind turbines in Buffalo Ridge. So the map to the left shows Minnesota as a whole, and the yellow box within Minnesota is the 19.1 by 19.1 kilometer area needed for both solar panels and wind turbines. And the map to the right is a close-up, and it shows the 117 wind turbines and the 45 kilometer squared area of solar panels that would be needed to provide for all of Minnesota's electric and transportation needs. So Minnesota's electrical needs could be generated by a 19.1 kilometer by 19.1 kilometer wind farm in Buffalo Ridge. Residents may be hesitant to support such a project for fear it will take up too much space, but in all actuality, Minnesota is 225,181 kilometers squared, and the potential wind farm is only 364.81 kilometers squared. So the potential wind farm would take up approximately 0.162% of Minnesota's total area. This area is significantly less than the area Minnesota currently reserves for energy production. And these undisturbed areas of a potential wind farm could be utilized for additional energy production. The 45 kilometers squared of solar panels could be situated within this undisturbed area of the potential wind farm. These solar panels could easily generate enough energy for each licensed driver in Minnesota to drive a Tesla Model S car. So Minnesota's energy needs for electricity and transportation could be completely satisfied by renewable energy and also be generated within a 364.81 kilometers squared area. Thanks for listening.